Hello, happy Tuesday. I hope you all had a really good weekend. Today we are going to be learning a new type of factoring that actually combines the skills that we've had before. So let's go ahead and take a look. First off, real quick, all of your missing assignments should be down here for late credit available. You guys can get credit for anything that is missing, so don't forget, if you have something that's not 100%, feel free to work back on those and get those grades up. So here are the assignments for this week. Let's go ahead and start with Tuesday assignment. We have factoring quartic trinomials. Factoring quartic trinomials. All right, and here is what we are looking at. We are looking at x to the fourth minus 2x squared minus 3. Now this is a trinomial. This should look very similar to what we've done in the past. The only difference is instead of an x squared, we have an x to the fourth, and that's going to change one small thing. All right, so I'm going to go ahead and write this out. I have x to the fourth minus 2x squared minus 3. All right, first off, I don't see a GCF. I don't see anything I could pull out. It's not a difference of squares. We are going to have to factor this just like a trinomial. All right, now, usually we have x squared, and I say this breaks up into x and x, but I have an x to the fourth, so this x to the fourth is going to break up into x squared and x squared. All right, now I need two numbers that multiply to -3 that add up to -2 here. Well, two numbers that multiply to -3 that add up to -2, well, that would be -3 and +1. Go ahead and check yourself here. If I were to multiply this out, x squared times x squared would be x to the fourth. X squared times +1 is plus 1x squared. -3 times x squared is -3x squared. And then finally, -3 times 1 is -3. And if I were to combine that +1 and -3, that ends up with -2. All right, I am going to look just to double check to see if I could break this down further. Right here, it is kind of possible that we have a difference of two squares, but this is not a perfect one. I'm hoping we see an example where we can break that down further. But nothing times itself is 3 in the whole numbers. So our final answer is this. We have x squared minus 3, x squared plus 1. And that looks good. All right, let's do another one. All right, so here we go. We have x to the fourth plus 3x squared minus 4. All right, same thing. Looking at this one, we do not have anything that I could pull out, no GCF. Only difference is I have x to the fourth. So x to the fourth breaks up into x squared and x squared. And this time I need two numbers that multiply to -4 that add up to +3. Multiply to -4 that add up to +3. Well, that would be +4 and -1. If I were to multiply that out, x squared times x squared is x to the fourth. I have a -1x squared, a +4x squared, that is 3x squared, and then finally 4 times -1 is -4. However, but wait, there's more. I do see a difference of two squares right here. I have an x squared minus 1. So when I finish this problem off, I could actually break this up even further. Looking at this, x squared can be broken up into x and x. And this is a difference of two squares. So I want that middle term to cancel out. This will be +1 minus 1. All right, so first step, I broke it up into two numbers that multiplied to -4 that added up to +3. And then once I got to this side, my -1, I do have a difference of two squares. And just like we've been doing since before break, that breaks up into x plus 1, x minus 1. This one's not going to break up because that's a positive. That's not going to work out in the whole real numbers. All right, so our answer here is x squared plus 4, x plus 1, x minus 1. All right, let's do one more. All right, looking at this one, I have x to the fourth minus 14x squared plus 45. All right, here we go. Let's see what I can do. I have x to the fourth minus 14x squared plus 45. All right, looking at this, I don't have a GCF that I could pull out. X to the fourth breaks up into x squared and x squared. All right, I need two numbers that multiply to 45 that add up to negative 14. Well, that one would be negative 5 and negative 9. Negative 5 and negative 9. Think about that. Negative 5 times negative 9 is positive 45, and negative 5 plus negative 9 is negative 14. Now we're always on the hunt to see if there's one of those that I could break down further, and there is one that is a perfect square here. X squared minus 5, well, 5 doesn't break up into anything that's a whole number, but 9, that one does. So here's our final answer. X squared minus 5, and then if I have x squared minus 9, I have x plus 3, x minus 3. Those break up perfectly. So this is my final answer. That's as far as I can go. Let's go ahead and type that in. X squared minus 5, x plus 3, x minus 3. And there you go. All right, so your work today is to finish these 10 problems like that, and then you will have 5 that are mixed methods that go all the way back from the very, very beginning. And don't forget, if you forget how to do a certain problem, you can always click show an example, and they will help you out. All right, have a wonderful day. Feel free to email me if you get stuck on anything.